All right, looks like we are live. If you're here early, thank you for being here early. Um, Let me just make sure the volume on my mic is good. Give me a plus in the chat if you can hear me before we get started, so I'm not just talking to myself. Welcome to today's free lesson on Algebra 2. Today is a new lesson from last week. We're talking about solving basic equations this week. I believe last time we talked about systems of equations, I believe, by substitution. Hi, Raymond. Welcome. Wow, looks like I can see the chat a lot faster today, hopefully. Um, I changed some settings, so I'm able to see chats faster, hopefully today. Fingers crossed. But yes, we are talking about solving basic equations, but in Algebra 2, basic equations can look a little different. In Algebra 2, we're going to start getting used to getting more comfortable with uncomfortable looking solutions, like fraction solutions, having radicals, having bigger numbers, things like that. So Algebra 2, that's what it's all about. It's Algebra 1 at a deeper level, and we are going to get more comfortable with uncomfortable answers. And that's what Algebra 2 is all about. Before we get into, pre-calculus, calculus, and all that. Avery, welcome. Welcome, welcome. All right. Well, you can access today's workbook. It'll be the first link under the YouTube description, under the YouTube video. In order to chat today in the YouTube live stream, you will have to subscribe to my channel in order to chat. Feel free to unsubscribe after today's lesson if you did not enjoy it, and so you don't get any notifications in the future. However, in order to get the full experience as to what you would be getting in my course for all my lessons, I would highly recommend that you subscribe just for now, just so you can chat in the live lesson, so you can see how I interact with you and things like that. I can say hi to you, you can say hi to me, and just interact overall. Yes, Raymond is modding for today. Thank you for being here, Raymond. Appreciate it. All right. Well, hi, Madison. Welcome. We have some returners here. Before we get started, if you would like to share that URL, copy and paste it into your group chats, send it to your friends, send it to your family members, be supportive to your community. If you think they'd be interested in any Algebra 2 lesson, this is completely free. So you can share it with them, see how they like it. Maybe they'll learn something new today that may help you on an upcoming test in your Algebra 2 course. Yes, of course, Avery. Of course, I remember you. I remember all my returners, especially because I noticed how quickly you guys are able to type in the chat because you're already subscribed. But yes, welcome back. Thank you for being here. I'm really excited to show you what I've planned for you today. It's a completely new lesson from last week, so hope you learned something new today. All right, just a quick intro of myself. For those of you that are new here, I'm Eddie. I've been teaching high school and college math classes for 9 years. I've also private tutored every grade level from 6th grade math all the way to students preparing for graduate school, like the GRE and things like that. I did really well myself in school. I got A's in all my math courses, got a perfect score on the SAT, and that's how I ended up getting accepted into my dream school, UCLA. After graduating from UCLA with a math degree, I decided teaching right away, and I quickly learned I was super passionate about teaching mathematics. And it showed because my students have gotten into the top universities in the nation. They've gotten perfect scores on their SAT, fives on their AP exams, and just have performed above the national average on almost every metric possible. But most importantly, they had fun doing it. And that's what we're here for today. We're here to have fun learning math. I want to make math affordable, accessible, and fun, right? That's the most important part. And that's how we will be going about it today. Avery said, yes, it shows notification on my phone that you are live. Amazing. Yes, notifications on. We love that. Okay, to access some prior knowledge, we're going to work with fractions. We're going to be working with a lot of fractions today. So by the end of today's lesson, you will be able to, 1, be really comfortable with fractions. 2, you're going to be able to solve quadratic equations, both by factoring and using the quadratic formula. And 3, you're going to get really comfortable with messy looking solutions, but there'll still be our real solutions to these problems. So let's dive right into our first question here. Using fractions operations from last lesson. So this is one of the lessons that you'll be getting in the course. That's why it says last lesson. In the previous lesson, we might have talked about fraction operations in solving equations. Solve this equation right here. X over 2 plus x over 3 equal to 20. What do you think would be the very first step in solving this problem? What do you think would be the easiest way? Or maybe a way that you are most comfortable with. I always say I might show it one way, but if you're more comfortable using a different method, by all means, use that method, because that way you will not make any careless errors and you're not learning anything new, doing anything new that could possibly harm you in the long run. But I will say every method that I use in my lessons is tried and true. I believe that students will have a lower probability of making those careless errors, especially on exams when you have, a lot of problems to solve, and it's timed and things like that. I believe my methods are tried and true, and that's how I will be going about it tonight. But if you have any suggestions, feel free, participate, chime on in, and I'd be more than happy to respond to those. But what is the first thing that comes to your mind when you are trying to solve for x here? For those of you that are here today, what would be the first thing you would do here? No wrong answers, as long as you're comfortable with it. We need to make the denominator similar. Common denominators. That's a great idea, Avery. We need to make it 6. Let's do it that way. So the first thing we would do here is I would say, all right, since our first denominator is 2, I want to make that a 6. So I'm going to multiply both the top and bottom by 3. So we have x over 2. I will multiply both top and bottom by 3. The next one, for x over 3, I would multiply this by 2 over 2. Since my denominator is already 3, I want to make it into a 6. The 20 will stay the same. And now we have a common denominator on the left side of our equality. We have 6 as our common denominator, and now we have 3x plus 2x, and that will be equal to 20. I can combine like terms in the numerator. That will give us 5x, and also multiply both sides by a 6 to cancel out the denominators on the left. That equals 120, and we can divide both sides by 5. Our final answer will be 24. Now, let me show you a new way of doing it. This is perfect, Avery. That first step was perfect. Let me show you a new way of doing it. It's basically the same thing, but I'm going to be multiplying both sides by 6 right away. So what I'm doing here, instead of looking for common denominators, I am looking for the least common multiple of the denominators, or basically the common denominator, the lowest common denominator, and multiplying both sides by that number. That would give us 6 times x over 2 gives us 3x. 6 times x over 3 gives us 2x. And on the right side, we have 6 times 20, which is 120. That'll give us 5x is equal to 120, and x is equal to 24. Now, just to clear the air, both are correct. Both ways are correct, but I would highly suggest that the way that we just did it on the right side of your screen will lead to less careless errors in the future. Okay. I forgot to change my screen mode so that you can see my screen better. There we go. Hopefully that's better. And that's how we will be solving these first couple problems. If you have any questions throughout today's lesson, please feel free to ask in the chat. That's one amazing thing about these live lessons, is that I get to interact with you in the chat. In schools, on average, the research shows that students often raise their hand or participate in a 1-hour lecture or lesson 1 or 2 times, because there's so many students in the class, 1 or 2 times. However, in live lessons, I've had an average of about 7 to 9 comments per participant. And that's way more than 1 to 2, right? And that's why these live lessons are so beneficial, especially for those students that aren't just getting the help that they need in school. And that's what we're here for today. I would like for you to practice that tonight as well. Like Avery already has like over 5 comments in the chat, and that's amazing. So don't be shy. Make your mistakes. One more thing. Research shows that when you make a mistake and you fix it, that's when true learning occurs. That's when true retention and true learning occurs, so that the next time you see a problem like that, or a concept or skill that you have to use, you don't make that mistake again, right? Or you're less likely to make that same mistake. All right, let's take a look at these. So we're going to solve these the way that I suggested in our APK, our Access of Prior Knowledge. Now we're solving with numeric denominators. Later on, there will be variables in our denominators, so it will get more challenging. So for those of you that have just joined and are thinking, wow, this is too easy, this is not Algebra 2, these are how all my lessons will be. In the beginning, I allow very many re-entry points so that you are sticking with me through the lesson, so that by the end, when we are working on those more challenging problems, you're good to go. You might be able to solve them on your own without my help, right? But I will still be there to model it for you and get you to that end. Let's solve letter A first. Letter A says x over 5 plus 2x over 3 equal to 26. Now, from Avery's suggestion earlier, finding a similar denominator, a common denominator, that number here would be 15. But instead of using common denominators, this time we will be multiplying both sides by 15. Quickly in the chat, if you're good at mental math, let me know what 26 times 15 is for the right side of this. Great, Madison. Love it. 15. Awesome. I was saying 15 and I almost wrote 15. But the denominator here is 5. So we have 2x over 3, and this will be equal to 26 times 15. Now, for those of you that may not be familiar with this multiplication symbol, a dot means a multiplication symbol. I don't put the dot, or sometimes I do, but most of the time I don't, because the parentheses imply that we will be multiplying. So it is a bit repetitive. And we're in Algebra 2 now. We're grown, so we can start not putting that there as well. So now we have, great, Avery, 3x plus 10x. Awesome. 26 times 15. Let me give you a quick way of doing this. This is kind of like calculating tip, 15% tip. You multiply the 26 by 10, that's 260. And then half of 26 is 13, and you multiply that by 10 as well. And you take that half because 5 is half of 10. So you take 130 plus 260, that's 390. Boom, just like that. Awesome. So now we have 13x is equal to 390, and we divide both sides by 13. We get 30. Amazing. All good, Avery. You're going to get so good at mental math if you learn with me, because I'm going to give you all the little tricks here and there, and that's a huge benefit of, learning math from me or with me. Let's take a look at this next one. What would you multiply both sides of this equation by, now that we've done a couple of these? What would you multiply both sides of this equation by? X plus 1 over 2 plus x minus 3 over 4 is equal to 2. We want to multiply both sides by the common denominator, or the least common multiple of the denominators. The denominators here are 2 and 4. Avery, 8 is a great suggestion, but can we go lower? Can we go lower? 8 is a great suggestion, but we might get some bigger numbers here. Not that 8 is that big anyway. But what about, Madison helping us out with a question mark as well, 4. I love that we're thinking. I love when students put that question mark in the chat next to their answer. 4 is correct, right? Shows me that you're thinking. And we're multiplying here by 4 as well. Now, the 4s will cancel with our second fraction here. But with our first fraction, we're left with a factor of 2 in the numerator. So multiply 2 times x plus 1. Do not forget to distribute. So if I were to color code here, for those of you that might be struggling with that, I will be multiplying this top part by 2, because 4 divided by 2 is 2. And this top part will just be multiplying by 1. So that gives us 2x plus 2 plus x minus 3 is equal to 8. And now we combine like terms and solve for x. Now, this very first part, right, this very first part where we're multiplying both sides by 4 is the most difficult part about this problem. Everything else is just combining like terms. You could just, go on about it with your day, because 2 can be 4 times 2. Exactly, Avery. That's correct, right? 4 is the least common multiple of 2 and 4, right? 4 is both divisible by 4 and 2, just like 15 is divisible by both 5 and 3. Here, 3 and 5 didn't have any common factors. That's why we just multiplied them together to get the 15. But in our previous example, I believe, or 2 and 3 were also prime, so we didn't have to do anything there. We just had to multiply. But 2 and 4 have a common factor of 2. That's how we came up with 4 as our least common multiple. Great question. Looks like you got to the answer. 3x is equal to 9. 2 minus 3 is negative 1. Bring that negative 1 to the other side, becomes a positive 1. 8 plus 1 is 9. X is equal to 3. Okay, I think we're ready to keep going. So far, this is like the end of Algebra 1. I think we're ready to get into some more challenging things. Here we go. Looks different, but technically still the same. Okay, looks different, but technically still the same. If we want to make this more comfortable for ourselves, we can move all the terms with a variable to one side of the equality and everything without a variable to the other side of the equality. However, let's just try multiplying all the way through just like we've been doing without having to take that extra step. Okay, so letter A, we have 3/4 of x minus 12. I'm going to be multiplying this by something equal to 3/8 of x. Okay, let's see. What will we be multiplying both sides of this equation by in order to get rid of the fractions? Now, there are ways of solving this without getting rid of the fractions, but there are 3 moments, 3 things that cause the most number of errors that I've seen in my 9 years of teaching. Number 1, when we're working with really big numbers, students make so many mistakes. Number 2, when we work with fractions, we make so many mistakes. Number 3, negative numbers, we make so many mistakes. So I try to keep my numbers smaller. I try to not have to deal with fractions when we don't have to. And in this case, we don't have to. And 3, with the negative numbers, I try to keep everything as positive as I can. Every coefficient of a variable, I try to keep as positive. So these are some things that we'll be practicing in my course as well. 8 is correct. Denominator will be 8. The least common multiple for the denominator is 8. Amazing, Madison and Avery. We are getting better already. We're growing already. I see the growth. The speed, we love it. 8 times 3 over 4. 8 over 4 is 2. Times that 3 is 6. And don't forget, this 8 must be distributed to both terms, to all terms within the parentheses. So 8 times negative 12 gives us negative 96. And the 8s cancel out here very conveniently. Again, cancel and eliminate are completely different things. Here we use the word cancel because cancel turns into 1. Eliminate turns into 0. So we cancel out the 8s here, and we're left with 3x. And now we combine like terms, solve for x. This is the easy part. 3x is equal to 96. Oops, 96. And x will be equal to 32. Let me know what we should multiply b by and c by in the chat. B, we have 1/3 x plus 6 is equal to 5x minus 17 over 3. We're going to be multiplying both sides by something there. And then for letter C, we will also be multiplying both sides by something here. Equal to 1/2 x plus 4. What will we be multiplying the equation in B by and then the equation in C by? Great, Madison and Avery. For those of you that are shy and here on the stream, don't be shy. Participate. Madison and Avery being super brave. You see the question marks next to them, their answers. You know, just like we're doing great, right? We're trying, right? It doesn't matter if we make a mistake. Nothing here is graded. So you're doing great. For C, it will be 6. Great, Maddie. Or Madison. I don't know if you have been called Maddie before. I feel like I've said Maddie before in previous streams, but Madison. 3, yes, we will be multiplying both sides by 3. Great stuff, Madison and Avery. Let's multiply out by 3. 3 times 1/3 x is x, plus 3 times 6 is 18. Don't forget to distribute. That is also something that my students have struggled with and made careless errors with in the past. Now, here's something new that you may not have seen before. When I am working with these variables, get really comfortable. Great, Maddie. Get really comfortable with working with positive variables so that we can work with variables on either side. Right? A lot of math teachers are really scared of using the variable on the right side of the equality because they're scared the students are going to get confused. But in my experience, getting us really comfortable with using variables on either side of the equality is a very important tool, especially later on when you take pre-calculus, calculus, linear algebra, all that stuff. So this 15x is greater than the x. So I'm actually going to subtract x from both sides to keep the coefficient of x positive. Again, right? Our second most careless error, working with negative numbers. I'm trying to use only positive numbers here, at least for coefficients of the unknown variables we are solving for. We're going to add 17 to both sides to get 35. And so x will be equal to, I can leave the x on the other side as well. X will be equal to 35 over 14. And in simplest form, 35 and 14 are both have a factor of 7. So dividing both by 7 will give us 5 halves. If you want this in decimal form, that would be 2.5. And I saw, I think it was Maddie, say for letter C, we will be multiplying both sides by a 6. Does everyone agree? Do we multiply both sides by a 6 here? And you may notice this does wonders for us because now we don't have to multiply the 2x and the 1 by a fraction third, and we don't have to multiply x and 4 by a 1/2. Instead, what we can do is we can multiply by whole numbers. And this is way easier than having to work with fractions, and it incredibly decreases the probability of making any careless errors. Can we write in mixed fraction like 2.5? Absolutely every. That would be completely correct as well. Usually for these types of problems, if your teacher doesn't specifically state what your answer, in what form your answer has to be, any answer is correct as long as you're writing it correctly. Great suggestion and addition to the lesson, Avery. So we have 2 times 2x, which is 4x, 2 times 1, which is 2. We have 3x plus 12, and now we solve. 4x is greater than 3x, so I'm going to leave the x on the left side. 4x minus 3x is x, and subtract 2 from both sides. X is equal to 10. Voila, we're done. Welcome back, Zaira. Kalida-san, integration class? Oh, maybe. I'm not teaching calculus this year, but be on the lookout. I may have some AP Calculus cram sessions next semester when we get closer to the AP exams. Super excited for that. So stay tuned for that if you'd like some AP prep in the future. Trapius, welcome. Zaira, I said hi, right? Welcome back. I recognize. Oh, one something. I love differential equations, diffie-qs, love, love, love. But unfortunately, I'm not teaching calculus as a course this year, but eventually. All right. Now, the way we've been solving these problems really helps us when we get algebraic denominators. What that means is now we have a variable in the denominator. How would we work this out? So for letter A, we would multiply by whatever's in the denominator. And in this case, the least common multiple of the denominators. Now, x plus 2 and 3 don't have any common factors that we know of. So what we're going to do is we're going to multiply both sides. We're going to do exactly what we've been doing. We're going to multiply both sides by, let me color code this so you can see, x plus 2, and by a 3. So what does this do? This helps us to cancel out the denominators on both sides of the equation. So now you see why we were doing it the way that I suggested in the past, like 4 or 5 problems, right? Now this becomes so much easier, right? 3 times x minus 2 is 3x minus 6. On the right side, 2 times x plus 2 is 2x plus 4. We solve for x. X is equal to 10. Saved us so much time. Instead of having to try to find a common denominator, then trying to add them together on both sides, on one side of the equation, it gets super messy if you do it like that, and you'll probably make a mistake along the way. But this way guarantees or not guarantees, but significantly decreases the probability that you make a careless mistake. Let's take a look at letter B. What would you multiply letter B by then? Letter B says 2x minus 4 all over 3x minus 1. I'm going to leave some space here, equal to 3/4. What would you multiply both sides of this equation by? 3x minus 1 and 4 don't have any common factors that we know of. So what do you think we can multiply each side of this equation by to make this as simple as possible in our very next step? Great, Tropius. Great, Zaira. Love the energy. 3x minus 1 on both sides, which is the denominator on the left side of the equation. And also 4. Boom, boom. And now, when let me use the highlighter function. Let's have some fun here. We can cancel out the 3x minus 1s on the left, and on the right, we can cancel out the 4s. Ooh, that looks much nicer. I'm going to start doing that. And so now we have 2x minus 4 times 4, which is 8x minus 16, and 3 times 3x minus 1, which is 9x minus 3. Here is where we want to stay away from those negative coefficients, because that's going to make us do an extra step near the end. We can subtract 8x on both sides to get an x on the right side, and add a 3 to both sides to get negative 13. Boom, we're done. Let's try letter C. Letter C, we have 4 over 4x plus 1. The only thing I'm going to change for this one is that I have a 0 on the other side of the equality. This might be easier if we move that negative 3 on the left side of the equality to the other side of the equal sign. And that'll give us equal to 3. Little pro tip there. Now, what can we do to get rid of this denominator? What can we multiply both sides by here? I'm going to use green. I can multiply both sides by the entire denominator on the left side of the equality, right? 4x plus 1. 4x plus 1. This one might be the easiest one so far, right? And it only looks much easier here because we move that negative 3 on the left side of the equality to the other side of the equality. Great, Zaira. Great, Maddie. So now, let's use the highlighter function again. Just have some fun. 4x plus 1, 4x plus 1. Boom, boom. And now we have 4 is equal to, don't forget to distribute to all the terms in the parentheses, 12x plus 3. We subtract 3 on both sides, and now we know x is going to equal 1 over 12. So in Algebra 2, all this little kind of arithmetic order of operations that we do at the very end after that very first step, I tend to go a little faster. Let me know if you'd like me to go a little slower for that. But by Algebra 2, I am assuming that these smaller ones, of course, when we were working with bigger numbers, I'll pause to help you with those mental math strategies. But for little ones like this, I'll just be going straight through, especially because we're still near only halfway through. Wow, it's already 30 minutes. That time flies when you're having fun, right? But we're about to start getting into more of the challenging problems, and we want to get there, right? We want to get to that level by the end of each lesson, get to that mastery level, so that when you see this in school, you're like, this is chump change, super easy, because Eddie taught me how to do these. Let's check these out. We have 12 over x minus 4 is equal to x. Now we have variables again, but this time we have a little twist. Let me start A up here this time. A is 12 over x minus 4 is equal to x. And we're going to do the same thing that we've been doing. And this part I'll just do for us. We're going to multiply both sides by x minus 4. And what do we get on the right side now? Can anyone tell me in the chat? What do we get in the right side here? We have 12 on the left. Oops, I want to use red here, just so I'm keeping it consistent. 12 is equal to x times x minus 4. Tropius has an answer, x squared minus 4. That is a difference of squares. I love seeing difference of squares. X times x is x squared. So Trapius, you're correct there. X times negative 4 is negative 4x. So our practice from our previous problems, this is where that comes in, right? Being cognizant and being aware that we must distribute that coefficient of the parentheses to all terms in the parentheses. So keep that in mind next time. I love that you're participating though, Tropius. You made this mistake now. When you see this in school, ain't no way you're making this mistake again, right? Love that. So now, this is a quadratic expression, a quadratic equation. Whenever, in bold, I would like this to show up on the screen if I could. In bold, whenever you see a quadratic expression or equation, move everything to one side, set it equal to 0, so that we may be able to factor. Our favorite F word is factor, okay? When we can factor, everything becomes so much more beautiful. So let's do that. Let's move everything to one side, set it equal to 0. So we have x squared minus 4x. I can move this 12 to the other side. It becomes a negative 12. And now we have everything on one side set equal to 0. Now, how do we factor? Does anyone know how to factor? There are so many methods, right? Box method. There's, I don't know, like a crisscross, the X method. Name all the factors and try to find a combination. But the more you do these, the better you get at them. The way that I teach my students is I use the add multiply method. Add, multiply, AM. Add, multiply. What two numbers add up to negative 4 and multiply to negative 12? And it's always easier when you find factors of negative 12 to then add them up to get to negative 4. And in this case, what would those two numbers be? What would these two numbers be? What two numbers multiply to negative 12 but add up to negative 4? Great, Efren. I see you've given us an answer here. X minus 3 times x plus 4. Great answer. Let's check that out. If we have negative 3 times positive 4, that is negative 12. Boom, that's correct. But if we add negative 3 and positive 4, that gives us a positive 1. So this is how we get better at this, right? We try, trial and error. That's the best way to learn factoring, trial and error. Let's see what Zaira and Tropius have for us. Looks like we have the same answer here, negative 6 and 12 and 2. Let's check it out. Negative 6 times 2 is negative 12. And when we add negative 6 plus 2, that gives us the negative 4 that we need. Beautiful. Negative 6 and positive 2. Now, when we solve this, a lot of math teachers teach it this way. And I've seen it firsthand. They say, just flip the symbol. Just flip the sign. We're not doing that with me. We're not just flipping the sign. Because once you learn it that way, and we get coefficients for x, that's when you're going to start making mistakes. So what's actually happening here is that if we have two factors multiplied together to get 0, either of them can be 0, right? Because anything times 0 is 0, and 0 times anything is also 0. So we set x minus 6 is equal to 0, and x plus 2 is equal to 0. I am all about building a solid foundation, building good habits. That's what school is for, right? That's why we go to school. We go to school to build good habits, right? It's not just learning about our history, learning science, learning English, learning math, all these subjects. These subjects are there not for just like common knowledge, but also to build good habits. And we start that by starting from the start, right? From the very beginning. So back to the basics, back to the foundation. X minus 6 can be 0, and x plus 2 can be 0. Because if either of these are true, we don't care what the other term is going to be, because anything times 0 is 0. That's how we get x is equal to 6 or negative 2. And either of these work for this problem. We can always check. 12 over 6 minus 4 is 2. 12 over 2 is 6. Great. 12 over negative 2 minus 4, that's going to be negative 2. Excuse me. All right, let's try letter B. Letter B. We have x minus 8 over x minus 1 is equal to 3. All right. What can we do here to make this a little simpler? In our first example, we had just the fraction by itself. So let's try to make that a theme. Let's try to keep the fraction by itself on one side of the equation if we can, and move everything else to the other side. But in this case, again, I'm going to try to keep everything as possible, as positive as I possibly can. So I'm going to add 8 over x minus 1 to both sides and subtract this 3 on both sides to get x minus 3. Now from here, what can I do? I can multiply both sides, but what can I do here? What can I multiply both sides? I know the elbow cuff. What can I multiply both sides by here to keep moving in this problem? I'm going to put the parentheses here first. And don't get scared of the parentheses, right? Think back to our APK. Think back to the very first problems that we've done. Tropius, I love the question mark. Zyra, I love the confidence. How sign is changed? Okay, great question. We can multiply both sides by x minus 1, but to answer Kalida-san's question first, you can think about it like this. This is the way that I teach it. If we have a number line and we have 0 on the number line, treat that as the equal sign. Whenever you have something positive and you switch it over, it becomes negative, right? So you multiply it by a negative. And whenever you switch back over this side, you multiply it by a negative as well. Oops, not a negative 0. I meant to circle the negative like this, right? So that's how this negative 8 over x minus 1 became positive on the right side of the equality, and the 3 here became negative on the other side of the equality. This always works when we are adding or subtracting terms on either side of an equality. All right, now let's distribute. The biggest mistake students will make here is that they'll forget that middle term, okay? So don't forget to completely distribute. X times x is x squared. X times negative 3 is negative 3x. Negative 1 times x is negative 1x. So in total, we have negative 4x's. And negative 1 times negative 3 is positive 3. Now, thankfully, the x over 1, x minus 1s cancel, which is what we wanted. And now we just have an 8. Again, this is a quadratic equation. Great, Kalia-san. This is a quadratic equation. Whenever we have a quadratic equation, and we recognize quadratic equations by a degree of 2, a degree meaning the highest power is a 2 in the equation. We want to move everything to one side, set it equal to 0, because we might be able to use our favorite F word, factor. Now, what two numbers multiply to negative 5 and add to negative 4? What two numbers multiply to negative 5 and add to negative 4? This one's a little simpler than our previous one because 5 only has 2 factors, 1 and 5. It's prime, so you can just play around with those. We know that one of them has to be negative because the product of those two terms will be a negative 5. So we know one of them has to be positive, one of them has to be negative. And since 4 is negative, we want the bigger number to be negative. Great, Tropius and Zyra. Negative 5 and 1. Multiply them together, we get negative 5. Add them together, we get negative 4. Again, this is all trial and error, right? For those of you that are getting this right away, you must have practiced this many, many times for you to recognize and just do this mentally in your head without having to write it down. But if you have to write down all the factors at the very beginning, do that because that'll build a very solid foundation for you and also increase and build your mental math skills. So now, x plus 1 can be 0 and x minus 5 can be 0. And that's how we know x can be negative 1 or 5 by using order of operations. Let's try this last problem, letter C. Letter C, the first thing I'm going to do here is I'm going to move this x to the other side of the equation. And I can multiply both sides by the denominator, x minus 2. Now we're comfortable, right? Now we're more comfortable with these, so I'm going to go ahead and solve this through. The x minus 2's will cancel, leaving us with just a 4 on the left side of the equality. Great, Maddie. And now when we distribute this completely, we'll have 7x minus 14 minus x squared plus 2x. Now, notice how this negative x squared has a negative coefficient. I like to keep my leading coefficient positive at all times because, again, remember our third rule for careless mistakes? It was fractions, positive numbers, and negatives. We want to keep everything positive when we can. So I'm going to move everything to the left side. I'll have positive x squared. 7x plus 2x is positive 9x. But when we move it to the other side of the equality, it becomes negative 9x. And when we add 14 to both sides, I get plus 18 is equal to 0. Now, do we know any two numbers that when we multiply them together gives us a positive 18, but add up to a negative number? So here's a little trick for those of you that are new to factoring or struggle with factoring. I know that two numbers multiply to a positive number, but add up to a negative number. Can you see why both of those numbers must be negative? A negative times a negative is positive, and add two negative numbers, you'll still get a bigger negative number, right? So now, what two numbers multiply to 18 and add up to 9? -6 and -3. Tropius is a beast at this, and I can tell Zyra will be answering soon as well. Maddie as well very soon. -6 and -3 is correct. And so now we can write x is equal to 0, or sorry, x minus 6 is equal to 0, or x minus 3 can equal 0. So therefore, x is equal to 6 or 3. Boom. That's how we solve these types of problems. Let's keep this going. It gets a little more challenging. So now let's take a look at these. Great Tropia, Zyra, Maddie, amazing work in the chat. Let's take a look at letter A. We have 2 over x squared minus 5 over x equal to 3. What can we multiply both sides by here? Share your thoughts in the chat. Think about it. I want to see those question marks in the chat as well. If you're unsure, that tells me that you're thinking, and you've come up with an idea. Might not necessarily be correct, but I know that you're thinking. Maddie, x is a great suggestion. Let's try that. See what happens. If we multiply both sides by an x, will it get rid of all the denominators on the left side? Let's think about that, right? That's the question we want to be asking. Will we be able to get rid of all the denominators on the left side? Zyra, I love the x squared minus x. That's a great idea as well. However, do you notice that the two fractions are separated? If we had a denominator of x squared minus x, your idea would have been perfect, Zyra. So I like the way you're thinking. Maddie, I also like the way you're thinking. Tropius actually gave us the correct answer here. Or not the correct answer, but the best way of doing it. So kudos to you. X squared would be perfect. Why? Because when we multiply x squared by 2 over x squared, those cancel, right? And then when we multiply x squared by the -5 over x squared divided by x leaves us with just 1x. So what we get here is 2 minus 5x is equal to 3x squared. Boom. There is our quadratic equation. And now we can try to factor by moving everything to one side of the equality, setting it equal to 0. Let's try that out. And again, I like to leave my leading coefficient positive. For those of you that are unfamiliar with that terminology, a leading coefficient is the coefficient of the variable with the leading power. So 3x squared, I'm going to leave on the right side, move the -5x to the other side of the equality. It flips signs. So does that +2 to a -2 equals 0. Now, can we factor this? Well, this one's a little different, right? Because our leading coefficient is no longer 1. So we have 3x and x here. We need two numbers that multiply to a -2, but one of those numbers is going to be multiplied by 3 when we're adding it up to get that 5. Well, thankfully for us here, -2 only has 4 combinations. It has +1 and -2. It has -1 and +2. It has 2 and -1, or -2 and 1. Let's try all of these. I've heard this called the oi method, the outside, inside method, OI. That was really fun. I think I got it from Neil. I think that's a great way, fun way to remember it, the oi oi, outside, inside, outside, inside. So 3x times -2 gives us -6. 1 times x is 1x. So we have -6 plus 1x. That gives us a -5x. So we know that this one does not work. Next, the next one gives us 3x times 2, which is positive 6x, times -1 times x, which is -1x, and that gives us that positive 5x. Bingo. It only took us 2 tries. We only had 4 combinations. The probability you get it on the second or third try is pretty high. And if you get it on the fourth try, maybe you were just a little unlucky that day. All right. So this is where setting either of these terms, these expressions that are being multiplied equal to 0 becomes a huge foundational skill that you have built now. If your teacher just tells you to flip the sign, if you flip the sign for this first one, you're saying x is going to equal 1. However, that's not true. You must consider 3x minus 1 is equal to 0 and x plus 2 is equal to 0. Therefore, 3x is equal to 1, x is equal to 1/3, and or x is equal to -2. So either of these x values should give you a true statement for our very first equation on this slide. Let's try the next one. Let's check letter B out. And after letter B, we have one more problem. It's the beast problem. I always love ending every lesson with like a more challenging problem just to get you past what what you think you're capable of. And that's what I love doing as a teacher. I love to push you to your limits and eventually past your limits. And you're going to achieve things that you didn't even know were possible for yourself. That's my job. Where did you get the 6x from? Great question. I did 3x times the positive 2, and then the second one came from -1 times the x. Yes, Tropius, thanks for helping out as well. Right? It just feels like a classroom and we're just chatting in the live chat without disrupting the teaching at all, right? It's a beautiful thing. Yes. Love that. All right. B says 1 over 1 minus x is equal to 4 plus 3 over 2x minus 3. What can we multiply both sides by here? This one is a little trickier, so I'll give you some time. Ooh, didn't want to do that. How do I undo? That would be very useful at this time. Screen. Oh, well, okay. I mean, all my lessons, again, are recorded, so you can always go back to that later on as well. I will try to find that undo button in the future. Is it this? What does this mean? I don't want to press anything wrong. But let's keep going here. Good thing for us is now we have more space to work with. So now we have 1 over 1 minus x is equal to 4 plus 3 over 2x minus 3. What can we multiply both sides by here to get rid of these kind of intimidating looking algebraic denominators? What can we do here? Ooh, Control Z might be a good idea. Unfortunately, Control Z is not working, but great idea, Efren. What can we do here? We can multiply both sides by, let's do the same thing we did with the numbers. We can multiply by 1 minus x on both sides. And that will cancel out these. And then the 2x minus 3. Great idea, Tropius. We can multiply both sides by 2x minus 3 as well. 2x minus 3. And those will cancel out on the right side of the equation. But we have to be careful. We have to be careful not to cancel it out right away because we still have to distribute this 2x minus 3 to this 4. So be careful here. Be very careful. So now we have 2x minus 3 on the left side. On the right side, we're going to have 4 times both of these expressions. So we have 4 times, and I'm going to distribute these as we go. We have 2x minus 3 minus 2x squared plus 3x plus 3 times 1 minus x. And I'll write that out here, 3 times 1 minus x. And let's do all these out. So now we have 2x minus 3 is equal to 2x plus 3x is 5x times 4 is 20x. We have 4 times negative 3 is negative 12. Again, this part is not difficult, right? It's only considered challenging because many students make careless mistakes while going through the arithmetic, combining like terms and such. But in this case, negative 8 is our leading coefficient. I want to move it to the other side of the equality so to make it positive. So I'll be moving everything over to the left side. 20x minus 3x is 17x. Move it over to the left side. 2x minus 17x will give us negative 15x. Doing a little bit of mental math here. Negative 12 plus 3 is negative 9. Move it to the other side of the equality. That'll give us positive 6 equal to 0. Now, this one is a little tougher, right? This one will be a little tougher. Anyone off the top of their head know how to factor this one? I personally cannot think of any. So whenever we don't know, we use something called the beautiful quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Just like that. And we plug in all the numbers that we have. So we have negative b. B is negative 15. So we have negative 15 plus or minus the square root of b squared. What's 15 squared? Nothing but 225 minus 4 times a times c all over 2a. 2a. Quadratic formula. Yes. So now we have 15 plus or minus. We have 225 minus 4 times 8 times 6. So 4 times 8 is 32. 32 times 6 is 192. You can check my math on that. 32 times 6. Is that right? 32 times 6. 180 plus 12, 192. Yes, that's correct. So we have 225 minus 192. That gives us radical 33 all over 16. There are no perfect squares or anything like that here. So that is our final answer. X can be either 15 plus radical 33 over 16 or 15 minus radical 33 over 16. Let's look at our beast problem. Here it is. Okay, here we go. Now, what would you multiply both sides by here? This is our beast problem. If you understand this one, then you have gotten past your potential for today, which is amazing. And if you didn't, that's okay. The practice problems that come after the lesson will allow you to get another chance at mastering these problems. And believe it or not, you will have another chance to master these constant skills because I create detailed video solutions on every single practice problem you get after the lesson so that if you get those wrong, you can go to the problem that you got wrong and see exactly how I would have done it and learn once again. The denominator has too much, I know, right? But let's take a look. Both the denominators are a great idea as well. But whenever you have a quadratic expression in one of the denominators, here's what you want to do first. You want to see always, if we have a quadratic expression in the denominator, always check if it's factorable. Again, right? Our favorite F word in Algebra 2, in pre-calculus, in calculus is going to be factor. Factor, factor, factor. We love when a quadratic expression is factorable. In this case, it is. It is x plus 5 times x plus 3. And guess what? These two denominators have a common factor of x plus 5. So we can multiply both sides. This is exciting. Both sides of the equality by x plus 5 times x plus 3. Boom. And I don't know why I put the bigger parentheses, but more the merrier. And now, when we, distribute, both of these factors will cancel out with both of these, leaving us with just an 8 for the first fraction. And for the second fraction, notice how the x plus 5s will cancel, but the x plus 3 still remains. And I'll do it step by step here. And on the right side, we'll have 2 times x squared plus 8x plus 15. And now let us distribute. The easy part is left. So we have 2x squared plus 16x plus 30. Notice how my leading coefficient of 2 is positive on the right side of the equality. Let's leave everything on the right side of the equality then. No reason to move it all to the left. Negative 2x on the right side will give us positive 18x. 8 minus 6 is 2. Subtract, we get plus 28. Notice how everything has a common, what is it called again? Factor. So we can factor out a 2 as well. And this becomes a very simple factoring problem. I'm breezing through here just because I want to end on time. And so x is equal to -7 and or -2. Right, all this arithmetic factoring stuff, we already know how to do. The hardest part about this problem was finding what do we multiply both sides of the equation by to make this problem more bearable, less challenging, less likelihood of making a mistake. So if you're still here and you enjoyed the lesson, put a W or put a plus in the chat for a W stream today. And I have something very special I want to share with you. Call your parents over. This might be information that they might be interested in. Our lesson may be ending, but your progress doesn't have to. The MyEdspace Algebra 2 full year course taught by me starts on October 6th. So now less than 2 weeks until my course starts. You'll get 2 of these live interactive lessons each week, just like you had today. You'll get 2 of these each week, and all lessons are recorded, as mentioned before. If you have any extracurricular activities or family events and you miss a lesson, you can always go back to review. Or if your teacher goes over something like this later on in the school year, you already know how to do it, but you want to access the lesson again. You want to access the practice problems again. You want to access the video solutions again. All of these you can access all over again and revisit to review. But how much is it? For context, when I used to be a private tutor, how much do you think I used to charge per hour? A lot of you have been here before, so you know. But to give you a little bit of a backstory, in high school, I used to volunteer and tutor pro bono. Pro bono meaning for the public good, so it was completely free. And then in college, I used to charge about $30 to $40 an hour because I was a UCLA student as a math major. I knew how to do homework help and prepare them for tests, like little tests here and there, but I didn't really know what I was doing because I didn't have a degree. I didn't have a teaching credential. I didn't know what the teacher was going to be doing in the future. But now, after 7, 8, 9 years of teaching, I used to charge a minimum of $100 an hour, up to $200 for those that are taking like the GRE, really high impact exams that I know they need a lot of help with. And that's kind of the average here in Los Angeles. And that's the problem, right? Families have to choose between what works and what they can afford when it comes to tutoring. Effectiveness versus affordability. You never get both. And that's why we created MyEdspace. All of this for just $99 a month, which is 8 times cheaper. If you think about 2 engaging lessons, live lessons each week, that's about 7 to 8 lessons per month. So that'll be less than, I believe, $15 per lesson, $15 per hour. And why stop there? If you are able to pay for the annual package and you want to purchase the entire course across 8 months, we start on October 6th and on June 5th. Across 8 months, 60 live lessons, I give you a 20% additional discount. I think it comes out to something like less than $11 a lesson, which is absolutely insane. But that's what our mission is all about. And to protect you from any risks, we provide a 30-day risk-free full refund guarantee. If you take the course and after a month or within a month, you're like, oh, this is not it, full refund guarantee. But I mean, this is because we're very confident. I'm very confident that you will enjoy the course and you'll see a huge boost, not only in your confidence, but maybe also in your grades early on. This is a first come, first serve. Spots are filling quickly. It's a limited time offer. So if you're interested, text me at this number, my number, 512-900-1283, and me or one of my team members will get back to you ASAP. If you screenshot this, you can show it to your parents later if they're not around right now. You could also scan that QR code. It'll prompt you to send that code word start to this number right away, just in case you're scared of making a mistake typing in this number, which often happens. So scan that QR code. Tell your parents about this. We only have now less than 2 weeks. I believe it's something like 11 or 12 days until course start. So convince your parents, or parents, if you're here, if you think this is a good fit, feel free, message me. We can talk more about my course. And I look forward to speaking to you soon. Again, have a great rest of your evening. Thank you for being here. Special shout outs to Raymond, Zaira, Tropius, Maddie, Efren. There was one more, Kalida-san. Yes. Thank you for being here today, Avery. I think I said your name, but just to make sure. I love the energy, love the participation today. Hope you learned something new today and you feel more confident heading into, if you're in Algebra 2 and you're heading into some exam or tests very soon. Hope you're feeling more confident about this and hope to see you soon. Have a great rest of your evening, everyone. Bye-bye.